Sorry about that. Welcome back. And we will be continuing with example 3. And I just want to preface this with the fact that we are going to get in one of the more complicated parts of this. So you might need to actually watch this a couple times, or at least make sure you read through it a couple of times. The first part's relatively easy. We're going to be talking about range and standard deviation. What these things are really doing. It's saying how spread out is our data. So don't forget, the whole point of this section, you're just getting a list of numbers. That's what that is. It's a list of numbers that represents something. So you get a list of heights, you get a list of weights, you get a list of anything. It can be anything that can be measured. You get a list of it. Well, we want one number to represent the set. That was the whole first section, mean, median, mode. Which one of those three is the best? And we talked about how it goes in that order. You can look back in the other videos. Now we're going to look at another part of the data. We're going to look at how spread out the data is. So what that means is how wide the data is. If I have to talk about things, if I have 3 people and one is 5'5", one is 5'6", one is 5'7", the range is 2 inches. They're all very close in height. Now, if I have someone that is 5 foot tall, 5 and 6 foot tall, and 5'6", well, the middle number is still 5'6", right? But you see the spread of them is a foot wide. So that is what we're looking at. And to see it in numbers, it could just look like this. So if I just look at some lengths, that's 5 feet. Let's just do decimals, 5.5. That's 6 feet, right? Well, they'll average out to be 5.5 feet. But the range is the distance from the shortest to the tallest, 1 foot, okay? Well, you could have 3 people also. Remember, this one was 5.4 feet tall, 5.5 feet tall, 5.6 feet tall. Well, if you look, the middle number is still the same. The average, the median, everything is still the same. But our range is way different here. We would say these guys are all much closer in height than these guys. Okay, so that's what we're looking at. We're looking at range. So all you have to do to find the range is subtract the biggest from the smallest. That is it. So let's look at the first question that goes along with that. 2 reality cooking shows, select 12 contestants. The ages are here. So we have 2 groups, A and B. Find the range of the ages. This is pretty straightforward. You look in Group A. Group A, if you put them in ascending order from 19 to 31, 31 minus 19 will be 12 years old. So we can get their range pretty easily. The range for the second group, put them in ascending order. They both have the same youngest, but this one is a much older person. So this one goes up to 48. 48 minus 19, their range is 29 years old. Now, range is a good number to know. All it is a distance from the max to the min. You can find the range. That tells you a lot. It tells you how spread out the data is. So hopefully those questions aren't too hard. But now we need to look at something called standard deviation. Standard deviation. Standard deviation is something that takes into account all of the numbers. So what standard deviation means, let's look at the 2 words that make up standard deviation. Standard deviation. Standard just means regular, right? Deviation means change. So what we're saying is, what's the regular amount of change? So when we say standard deviation, don't get thrown off by it's a big word. All it means is regular change. From one number in the set to the mean, and we're comparing it to the mean, how much does that data deviate? So when you used our first set, if all the numbers are really close, you won't have much standard deviation. If the numbers are way different, you'll have a lot of standard deviation. So we're going to look at this because this tells us how spread out our data is. And what I mean is if I pick 5 numbers 1, 4, 7, 9, and 11. And then I pick 4, 5, 6, 7, 8. I should have picked some close numbers, but you can see these ones are far more spread out than these ones. Okay. So this would have a larger standard deviation than this, or regular change. Regular change just means how spread out is the data. Okay. But it looks at it in clumps. So now, if we go back and we actually look on the screen here, well, this formula is pretty tough for standard. You guys could figure it out. All you do is take every number in the set, subtract the mean and square it, and then you add up what you get for every single one of those things. Okay. And this is how it would look. So finding standard deviation, this is the typical way they show you. So this goes with your example 4. So if you look at example 4 on your notes, I'm trying to zoom in for it a little bit on you to that bottom camera. Right here, we're just going to take those numbers, and you can see you have groups A and B. So you just throw them in. Those are the original numbers. We found the mean to be 25. So you take all of these numbers and subtract that. So you see how you get -5, 4, -6, -3, 0. Then we just have to square all those numbers. -5 squared is 25, 4 squared is 16, etc., the whole way down the list. Okay. Now you add all those up and divide by n. In other words, you find the mean of the squared deviations. Sounds difficult, but it's really not that difficult. Now, the nice thing is I will not make you guys do this in class. So what we're going to do is we're going to shoot over to our Desmos, and I'm going to show you how to do this on Desmos. Now, there is one thing to remember on Desmos when you do this. It's going to be very important. So please make sure you're paying attention when we go over this. First, we have to put in a table. So if we are going to do monitoring progress, and I'm going to switch to the camera again real quick. We're looking at example 4, find the standard deviation for show A from example 3. So we're going to find the standard deviation of this group right here. Okay, so I need to go to Desmos and plug those in. So first I plug in 20, 19. You have to bear with me for a second. I don't have these preloaded. Okay. Now remember, this is still my set 1. If you have more sets up, you'll have to call it something else. But to find the standard deviation, all I do is I go over here to functions. I'm still under stats. This is important. You have to use standard deviation P. Again, that is STDEVP. There's 2 standard deviations up here. You have to use P. There's an explanation that goes between. These are actually 2 different things. This is what you want. So you just hit standard DP of X, and then you can type in 1. It'll automatically do sub 1, and you get 4.2. Okay. So the standard deviation, let me go back to our camera. So the standard deviation is, I forgot it already, 4.2. And that's me rounding it. Now let's talk about what this means. First, let's use the book explanation, and then we'll use a little bit easier explanation. So the standard deviation is about 4.2. This means the typical age of the contestant on show A differs from the mean by about 4.2. So all that means is when you see all these different numbers here, we have all the different ages. Sorry, I'm trying to get this up close. We have all the different ages we used. you see that they're spread out. Remember, we've already went over the range. The range went from 19 to 31. So that seems like it's a very large spread, but a lot of people are clumped in the middle. So the average person isn't that far apart. What they really are, the average person is about 4.2 years from the mean, meaning that middle number that we said for the mean, add it all up and divide. If I picked out anybody, they're probably about 4.2 years or less from that mean. That is what standard deviation means. It is the average numbers distance from the mean. And I know this starts getting hard because you guys haven't thought about this that much. First, learn how to write it. So when they say interpret your results, you can word for word write it out. The standard deviation of 4.2 means I am 4.2 years away from the mean. And after you say it a couple times and you get more familiar with numbers, it will make sense. Okay? So remember, on Desmos, all you have to do to find the standard deviation, go to your plus symbol, add an item, and you would add a table. Go to that table, put all your numbers in only under X1, not X1, Y1. And then it's standard deviation P X sub 1. That concludes examples 3 and 4.